Alright guys, welcome to Pre-algebra 4.6. We're talking about negative and zero exponents today. Alright, so let's talk about what we know first. We learned about the product of powers property, which told us that if you had x to the fourth times x to the ninth, you could turn that into x to the 4 plus 9, which would give you x to the 13th power. We also talked about the quotient of powers property, which said that if you had 4 to the 10th over 4 to the 6th, you could turn that into the 4 to the 10 minus 6 over 1. And that would become 4 to the 4th over 1, which would really just be like saying 4 to the 4th power. Alright, so what we're talking about today is similar to that, but we're adding another layer. Okay, so again, we're talking about negative exponents and exponents with the power of 0. Now, the first thing we'll talk about is this. Anything, it's item number 1. That's not a 1. That's more like a 1, but not quite. Anyway, anything besides 0 to the power of 0 is 1. So anything to the power of 0 is 1 except 0 itself. For example, 5 to the 0 power actually equals 1. 7 to the 0 power equals, you guessed it, 1. If you take negative 8 to the 0 power, you know what that equals? 1. Okay. Now, the one thing is, if you take 0 to the 0 power, and do that in your calculator real quick and see what happens. So pause the video, try that, see what you get. Alright, so hopefully what you'll see is you get what's called a domain error. Okay, what that means, you cannot do that. You cannot take 0 to the power of 0. Okay, so why might exponents of 0 matter? Well, if you had a problem that said this, m to the 0, n to the 4th, okay, and this is one term, that really means m to the 0 times n to the 4th, and if you were to simplify that even further, m to the 0, again, that becomes 1 times n to the 4th, and anything times 1 is just itself, so I could rewrite that as n to the 4th. And there you go. That would be the simplified version of that. Now, let's talk about negative exponents, okay? Negative exponents, item number 2. All right, so let's say you had 3 to the negative 5th, okay? And you were told that you need to write that expression using only positive exponents. What would you do? Well, any number, okay, that has a negative exponent can be rewritten like this, okay? Put a 1 in the numerator over, and in the denominator goes this, except you do not write a negative 5, you write a positive 5, okay? So if you were given 2 to the negative 6th, how would you rewrite that? Well, hopefully you would say, oh, put a 1 on top on the numerator and the denominator do 2 to the positive 6th. Okay. Now you might be given something like this. Right without a fraction bar. Okay. And they give you 1 over 7 to the 7th. And so you need to write that without a fraction bar. Well, how would you do that? Well, it works in the reverse as well. What we would do is write that as 1, so you keep the 1 on top in the numerator. And actually, I'm not even going to really call it the numerator. I'm just going to write the 1 right there. Okay, I'll write it in the middle. We're going to kind of get rid of the fraction. Times, so again, that 1 came from right there, times 7 to the negative 7th. Okay, and that came from right there. We pulled it out of the denominator, but when we do that, you have to make that 7 exponent into a negative 7. And what does that equal? Anything times 1 is itself. So that's like saying 7 to the negative 7th power. Okay, so this is the same as this. They're just written in two different forms, all right? All right, so let's try a couple more just to make sure we're solid on this. We're going to do some more writing only using positive exponents. And let's say we're given 16x to the negative 6th times y. All right, and they say write that using only positive exponents. Well, you have a negative exponent, and we know that we can write a negative exponent as a positive exponent, but we have to change things a little bit. Now the question becomes, who does a negative 6, the exponent, belong to? Well, he belongs to the x, okay? The negative 6 does not belong to the 16. He does not belong to the y. He only belongs to the x. So what we're going to do is we are going to move this x to the negative 6th down to the denominator, right? So he's going to go down there and he's going to become a positive 6. But what happens to the 16 and the y? Well, 16 has an exponent, an invisible exponent of positive 1. Y has an invisible exponent of positive 1. So they're going to stay where? Well, okay, so let's look at this originally. 16x to the negative 6th over y. Couldn't we technically say that's the same as saying 16x to the negative 6th times y over 1? Okay, well, if that's the case, then the 16 and the y are going to stay in the numerator. So I'm going to leave it as 16y. Now we said the x to the negative 6 drops down and loses the negative, so I'm going to do a little negative sign and x through it, so that it becomes now x to the positive 6, and you would be done. All right, so let's try another. Let's say we had 4x to the negative 2nd, and we're going to write that only using positive exponents. Okay. Well, what do you think we should do? Why don't you take a second, pause the video, try and figure this out, play when you're done, and we'll see if you get it. Okay, so the question is, well, first thing we should notice is, negative exponent. We're going to have to move something. Now, who does that negative 2 belong to? Well, in this case, he belongs to both the 4 and the x. That's what it means when you have it outside of a parentheses. That means it belongs to everything inside the parentheses. So really, that's like saying 4 to the negative 2 times x to the negative 2, okay? And again, this thing could be rewritten as 4x to the negative 2nd over 1, just like we could say 4 is the same as saying 4 over 1. It's the same thing. So anyway, let's get back to here, which means what we changed it to could also be said to be over 1. Still, we're not changing anything. But now we got to think about it. We're writing only using positive exponents. These are currently negative. Anything with a negative exponent needs to be moved where? The denominator, right? Okay. So what we're going to do is we're going to write another fraction bar, and we're going to move this down to the denominator. But what are we doing to that negative 2? Making it positive 2. So now on the bottom we have 4 to the positive 2 times, well, you got x to the negative 2. Again, anything with a negative exponent needs to move down to the denominator and drop that negative exponent and make it positive. So that was x to the negative 2 in the numerator. Now in the denominator becomes x to the positive 2. Now the question is, what goes up here? Well, up here, had I done this 1 times that, would that have changed the value? No. Taking something times 1 does not change the value. So let's just say that 1 stays on top. He did not have a negative exponent there, so he doesn't move down, so he stays on top. So even simplifying this a little further, I could say this is like saying 1 over, well, 4 to the positive 2 is like saying 4 times 4, which is 16. And x squared, we could just write x squared. We could simplify it even a little further by saying 1 over 16x squared. I just got rid of that multiplication sign. I didn't need it there. And we would be done. All right, so this stuff kind of takes a bit of practice to get used to. So I want you to pause the video and try both of these, okay? Play it when you're done and see how you do. All right, so this first one, number 6, we're going to write it only using positive exponents, okay? So we have a negative 8 as an exponent. That's the problem. So the question is, who does negative 8 belong to? Well, he belongs to the y. So both the negative 8 and the y need to move to the denominator, but you're going to drop the negative sign, right? So it becomes 3 stays on top, okay, because doesn't have a negative exponent, so he stays put, over y to the, not negative 8 now, but positive 8, and you'd be done. And this one right here, let's see. 4x to the negative second, y to the 6z to the negative third. Everything with a negative exponent, if we're going to write it using only positive exponents, everything with a negative exponent needs to move to the denominator. So he's going to move down. He's going to move down. But 4 and then y to the 6 are going to stay on top. So rewriting this, I'd be left with 4, y to the 6th, and then these guys both drop, and they drop down and drop their negative signs. Say it's a double drop, right? So you now get x to the positive 2 times z to the positive 3. Now, can you simplify it any further? Well, you have powers right here. This is a power, this is a power, this is a power, but they don't have the same base. So you can't actually simplify it any further, and we would say, hey, you're done. All right, so we briefly mentioned this earlier. Let's try another practice problem with this. We're going to write this without using a fraction bar. So if I had a squared over c cubed, and I say write that without using a fraction bar, what would you do? Well, hopefully you would remember that, oh, okay, if I have something in the denominator with a positive exponent, I can move that up and make that exponent negative. So what we do now is we have the a squared on top, he doesn't go anywhere, and we move the c cubed up, but instead of a positive 3 of an exponent, you're moving it up so it makes it negative. Okay, try this one. All right, so that's c. Well, we're going to write it without a fraction bar, which means that guy has to go away, and whatever's in the denominator also has to go away. So again, we're going to move him up and add in a negative sign. So we're going to have 4x to the 4th on top. That doesn't go anywhere. Now we're adding a y, but it's not positive 3. It's to the negative 3. Okay, and you'd be done there, and of course you'd be done there, and that's item number 9 there. All right, so now we're going to kind of get even a little more advanced, right? We're going to find the quotient of this, and we're going to write it without using a fraction bar. All right, so remember the quotient property says that if you have two powers, they're being divided, and they have the same base, you can do what to the exponents? Subtract, right? So this would turn into 5 to the 10 minus 13, the top exponent minus the bottom. Now, what does that become? Well, that's like saying 5 to the negative 3. And since we're writing the quotient without a fraction bar, here's how we would leave it. Now, if I said do the same problem, but write using only positive exponents, what would you do? Well, we had 5 to the 10 over 5 to the 13th. You would again say, well, it's like saying 5 to the 10 minus 13, which we would say, oh, well, that's like saying 5 to the negative 3, but in this case, we can only use positive exponents. So what do? Well, remember, this is when we move down, right? We go double down. We move this thing down because the negative 3 applies to the 5. It's his exponent. He moves down, or I'm sorry, the double drop. You drop him and you drop the negative sign. You cancel out that negative sign right there, and you will get 5 to the positive 3. But remember, it's in the denominator now, so it's over 1. So know that these two answers are the exact same. They're just written in different forms, and that helps us in different situations. Sometimes we want this, sometimes we want that. But you need to understand that they are both the same. All right, so one more. Write this using only positive exponents, okay? Well, you have a negative exponent there, that's the problem. Now, before we start thinking about moving stuff, let's think. This is a power, this is a power. They have the same what? Base. So what does that mean I can do to the exponents if it's a quotient or a division problem? Well, that means I could say that's like saying 7 to the 2 minus the bottom exponent, which is a negative 8. Now that's interesting because what that becomes is 7 to the, well, minus a negative means plus a positive, 2 plus 8, which would then give us 7 to the 10th power, right? All right, so there's one way of doing it, but what's the other way? Can you figure it out? Well, remember that anything with a negative exponent in the denominator can be moved up, and you make that exponent positive. So this, I'll rewrite the whole problem. This could be rewritten as 7 squared, but now we got to move this guy up and get rid of the negative sign, right? So what we would say is that's like saying 7 squared times 7, not to the negative 8 now, but to the positive 8. And the product property of powers says that if I have two powers in a multiplication problem, they have the same base, what can I do to those exponents? I can add them. And this way we would also get 7 to the 10th power. So either way you want to do it is totally fine. You're going to get the same answer. All right, guys, that's all I have for you. See you in class.